I know that the Tn is going to be found from Sn minus 1. And that's the reason is because if I take the sum of n minus 1 terms and I add the next term, okay, I'm going to end up with the sum of all those terms. So this represents all the sum of all the Tn's up to before Tn. And I add Tn, I'm going to end up with Sn. So the rearrangement of this formula ends up with that. So if I want to find out Tn, I can subtract terms. So this is an example here where I have S3 and S4, S4 and S5. Well, and we're told this is a geometric sequence. Actually, it doesn't say that, but we have to assume that. So I know that if I subtract, we can go S4 minus S3. If I take the first 4 terms and I take away the first 3 terms, I'm left with a 4th term only. Okay, and again, this works not just for our geometric, it also works for arithmetic series because that's the nature of a series. We're adding up terms. Not just with the arithmetic series, but in fact with any series. But this allows us to get T4. So in this case, T4, when I work this out, is equal to 81. Okay, well that's useful. And here, notice that I got consecutive terms, so I can do S5 minus S4, and that's going to give me actually the 5th term. Well, 363, what's my funny 363 minus 120 is going to give me 243, which is my T5. Well, now notice that I have consecutive T terms. Okay, if I have consecutive T terms in a geometric series, I know that T5 over T4 is going to give me R. So 243 over 81 gives me an R value of 3. So I can find, if I know R, I can probably work backwards here to figure out A. Okay, so I know that T4, what was T4? It's 81. So I know I have 1, 2, 3, 4. That's 81. I can work backwards, divide by 3, divide by 3, divide by 3. I know the first 3 terms are going to be 3, 9, 27. If I want to solve for S8, I probably, I can write out 8 terms, but again, I'm probably better off using my formula now since I have R and I have A. Okay, so these are the key parts. I'm going to write this down over here just to make sure I have it all compiled. A and R. Okay, A is 3, R is 3. So S8, my formulas depend on A and R. So I'm going to end up with A, R to the power 8 minus 1 over R minus 1. So I end up with, what's that going to be? 3 to the power 8 minus 1 times 3 divide by 2. Okay, so I get 9840 as my sum. Okay, so that's going to be S8. And I think I've answered the question. I've got my first 3 terms. I've got my S8. And again, the key is to make sure you see if you can get A and R. That generalizes things. And the property I used to get this was to use this difference of consecutive sums gives us the values for T. And once I found some values for T, I could divide to get ratios. Now notice, I want you guys to be very careful because if I divide S's, okay, this does not equal the ratios because there's pluses involved with our S's, right? So once I start involving pluses, that doesn't allow me to figure out times and divide math. It's actually very complicated. It becomes much more complicated when we do that.